In level 2, we will be simplifying radical expressions by multiplying and dividing, and also rationalizing, which means we can't leave a radical in the denominator. So I will teach you how to get the radical out of the denominator. When you multiply radicals together, you're allowed to multiply the insides. So if you had the square root of 2 times the square root of 3, I'm allowed to multiply those inside parts together, and that would be the square root of 6. I can do the same thing with a cube root. So if I had the cube root of 2 times the cube root of 3, that would also be the cube root of 6. And we are allowed to divide radicals too. So if I had the square root of 3 over the square root of 2, that is the same as the square root of 3 over 2. Same applies to cube roots. So if we had to multiply two radical expressions where parts of it have radicals and parts of it are regular numbers, we're going to multiply the radical parts together and we're going to multiply the regular number parts together. So first I'll multiply the regular number parts. Negative 3 times 5 gives me negative 15 out front. And then the radical parts, I multiply the inside, so radical 15 times radical 5 is the square root of 75. Then I have to simplify my radicals. So I make a factor tree for 75, and we get 5 times 15, which is 5 times 3, and we can take out a 5, and we're going to leave the 3 inside. Now the 5 that we take out needs to be multiplied by the 15, or the negative 15 that's already in front. So negative 15 times 5 gives us negative 75 out front, and then on the inside we just have a radical 3 left. If you have a radical expression raised to an exponent, you can raise everything inside to that exponent. So I would do negative 3 squared times the square root of 7 squared. And negative 3 squared is positive 9. And when you square a square root, they cancel each other out. So this is just going to be 9 times 7, which is 63. In this next example, I can just simplify inside first, or I could simplify each radical. So there's two ways to do this one. I could just go ahead and divide 16 by 4, and I get the square root of 4, and the square root of 4 is 2. Or I could have done the square root of 16 over the square root of 4. The square root of 16 is 4, the square root of 4 is 2, 4 divided by 2 is 2. Either way, I get 2 for my final answer. Now for the next example, since they're both cube roots, I'm allowed to put them under one giant cube root and do the cube root of 128 over 2. And then I can divide 128 divided by 2 first, which gives me the cube root of 64. And 64 is actually a perfect cube, but if we didn't know that, we would make our factor tree. And 64 is 8 times 8, which is 4 times 2 and 2 times 2, and 4 times 2 and 2 times 2. So our prime numbers are 6 2's, or two groups of 3 2's. And when we take out 2 2's, we get a 4 because we multiply them together. So the cube root of 64 is just 4. And you can always plug a cube root into your calculator to check and see if it's a perfect cube. If it's not, we have to do it by hand. But 64 is a perfect cube. It's 4 to the third power. Okay, and for our next example, 27 and over 4 can't really be simplified, so I'm just going to take the square root of both of these by themselves. I can do the square root of 4. It's a perfect square, so I get the square root of 27 over 2. But then I need to simplify the square root of 27. So I do my factor tree. This is 3 times 9 and 3 times 3. So I have one pair of 3's and one 3 that's going to have to stay in. So I end up with 3 radical 3 on the top over 2. In this next part, we are simplifying by rationalizing. It's called rationalizing a denominator. You're not allowed to leave a radical in the denominator. So to make it go away, you take whatever radical is in the denominator and you multiply the fraction by that number over itself. So I'm going to multiply this by radical 5 over radical 5. Now I'm allowed to do this because anything over itself is 1. So I'm really just multiplying it by 1. I'm not changing the value of the number. Now, when we multiply, we do top times top, and 10 times radical 5, since one's radical, one's a regular number, I don't actually multiply them together, I just write 10 radical 5. And on the bottom, when I multiply radical 5 times radical 5, I do multiply the insides together, and we get radical 25. Now, on the bottom, the square root of 25, that's a perfect square, it's just 5. So we get 10 radical 5 over 5. Now, we did that. That's why we did that. That's why we multiplied radical 5 by itself on the bottom, because that will always come out to be a nice whole number without a radical. And now we can simplify the regular numbers. 10 over 5 is 2 over 1, or 2 radical 5 would be our final answer. In this next example, we need the radical 3 to go away in the denominator, so we can just multiply this by radical 3 over radical 3. And when we do that, first we multiply the top times the top, and since they're both radicals, I can multiply them together. We get the square root of 6. And on the bottom, I can multiply the radical 3 times radical 3, and we get 3 radical 9. Now the square root of 9 is just 3, so we end up with 3 times 3 on the bottom, which is 9, and square root of 6 on the top. Now the square root of 6 can't be simplified, so that's as far as we can go.